There is a quiet assumption that governs most of our lives, that the world behaves in consistent, predictable ways, that gravity pulls downward, that time moves forward, that objects remain where we leave them. These assumptions are rarely questioned, not because they have been proven in every place, but because most of the time they appear to hold. Yet, there are locations on Earth where these expectations begin to loosen, not dramatically, not in ways that announce themselves clearly, in small, persistent inconsistencies. A compass that hesitates, a radio signal that fades without reason, a road where objects seem to roll uphill. At first, these things are dismissed. Measurement error, environmental interference, human misperception, and often, that is enough. But sometimes the anomalies repeat. They are observed by different people in different years under different conditions. And slowly, a quiet question begins to form, not about what we know, but about where our knowledge might stop. There are places on Earth where normal rules appear to shift, not break, not vanish, but behave in ways that are not fully understood. One such place has been studied for decades, another has been known for centuries, and in each case, the observations are real, the measurements are recorded, the explanations exist, but they do not always agree. So what happens when a place resists explanation? When every attempt to understand it reveals something incomplete? Is it the environment subtly altering the conditions? Or is it us misinterpreting what we see? In the early 20th century, a stretch of ocean in the North Atlantic began to attract attention. It was not marked on maps as unusual. There were no visible boundaries, no changes in color, no obvious disturbances, and yet, over time, a pattern began to emerge. Ships passing through this region occasionally reported unexpected navigational problems. Compasses would drift, then stabilize, then drift again. Radio communication would weaken or disappear entirely. In some cases, vessels arrived later than expected. In others, they did not arrive at all. The area would later become known as the Bermuda Triangle, a name that suggests certainty, but the reality is less defined. The reports were not always consistent. Some came from experienced crews, others were fragmented or incomplete. One of the earliest widely discussed incidents occurred in 1918. A large cargo ship carrying manganese ore departed from Barbados. The vessel was stable. The weather was calm. No distress signal was recorded. No debris was found. It simply disappeared. Years later, in 1945, a group of military aircraft on a training exercise reported disorientation. Their compasses appeared unreliable. Their position became uncertain. Communication grew confused. Eventually, contact was lost. A search aircraft sent to locate them also disappeared. These events were documented, not as mysteries, but as incidents, data points. Yet the pattern was difficult to ignore. Something about this region seemed to interfere with normal expectations. But what? Was it the environment or the interpretation of incomplete data? Over time, scientists and investigators began to examine these reports, not as isolated events, but as a collective pattern. One of the earliest explanations focused on navigation. The Earth's magnetic field is not uniform. There are variations, subtle shifts that can affect compass readings. In certain regions, true north and magnetic north align more closely. In others, they diverge. The Bermuda Triangle lies near one of these transitional zones. Under certain conditions, a compass might appear to behave unpredictably, but this alone does not explain everything. Another hypothesis involved weather. The Atlantic Ocean is known for sudden storms. Microbursts, rapidly forming systems, unpredictable currents. A ship or aircraft caught in such conditions could be overwhelmed before a distress signal is sent. Then there are methane gas releases. Under the ocean floor, large deposits of methane hydrate exist. If released suddenly, they could reduce water density. A ship passing through might lose buoyancy and sink rapidly. Similarly, methane in the atmosphere could disrupt engine performance. These explanations are grounded in physics. They rely on known processes, and, in many cases, they are sufficient, but not always, because some reports do not align neatly with these models, and that is where the uncertainty remains. Despite decades of study, no single explanation accounts for all observations. Some disappearances occurred in calm weather, others involved experienced crews familiar with the region. In certain cases, equipment was functioning normally until the final moments. Then, suddenly, something changed. There are also inconsistencies in the data itself. Not all reports were recorded with the same level of detail. Some were reconstructed after the fact. Others relied on memory, which is not always reliable. And then there is the issue of scale. The Bermuda Triangle is a vast area. Thousands of ships and aircraft pass through it every year without incident. If anomalies occur, they are rare, but they are persistent, and they resist complete explanation. So the question shifts, not from what is happening, but to why does it appear inconsistent? Is it a matter of incomplete data, or are there environmental variables we do not fully understand? Far from the Atlantic Ocean, in a desert region of northern Mexico, another unusual area has been observed. This location is often referred to as the Zone of Silence, a remote stretch of land where radio signals reportedly fail. The phenomenon was first noted in the 1930s. A pilot flying over the region reported that his radio ceased functioning without explanation. As he moved away, the signal returned. At first, this was considered an isolated incident, but over time, similar reports emerged. In the 1970s, a test rocket launched from a military base unexpectedly deviated from its course. It landed in this same region. During recovery efforts, engineers noted unusual interference with communication equipment. Compasses behaved erratically, signals weakened or disappeared. Again, these observations were recorded, studied, analyzed. One explanation points to mineral deposits in the soil. Certain materials can affect electromagnetic signals. Another theory involves atmospheric conditions, temperature gradients, ionization layers, localized disturbances. But like the Bermuda Triangle, no single explanation fully accounts for every report. And so, the pattern repeats. A place where normal expectations do not always hold. What do these places reveal? Not about mystery, but about limitation. Science depends on measurement, on repeatability, on controlled conditions. But the natural world is not always controlled. It is complex, dynamic, interconnected. Small variables can produce large effects. A slight change in temperature, a minor shift in magnetic fields, a brief atmospheric disturbance. Each of these can alter observations. And if multiple variables interact, the outcome may not be predictable. This does not mean the rules are broken. It means our understanding is incomplete. These locations are not exceptions to natural law. They are reminders of its complexity. When faced with unexplained events, the human mind seeks patterns. It connects details, fills gaps, constructs narratives. This is not a flaw, It is a function of cognition, but it can lead to overinterpretation. A series of unrelated incidents may appear connected. A rare event may seem more common than it is. This is known as availability bias. We remember what is unusual, we forget what is ordinary. In places like the Bermuda Triangle or the zone of silence, this effect is amplified because the setting itself suggests anomaly. So each new report reinforces the pattern, even if the underlying causes are different. So we must ask, are these places truly different? Or do they appear different because of how we observe them? There is a boundary between what we know and what we can know. It is not fixed. It shifts as our tools improve, as our models evolve, but it never disappears. Places where normal rules seem to change exist at this boundary, not because they defy science, but because they challenge its current limits. They reveal the edges of understanding, and in doing so, they remind us that certainty is always provisional. What we accept as stable today may be reinterpreted tomorrow, not as wrong, but as incomplete. So these places remain, not as anomalies to be solved, but as questions to be explored. They do not demand belief. They do not require conclusions. They exist quietly at the edge of explanation, and perhaps that is enough, because the value is not in resolving them, but in recognizing that not everything is fully understood. So what do you think? Are these places simply the result of complex natural processes? Or do they reveal something deeper about the limits of our perception? If you enjoy exploring questions like this, consider subscribing for more.